The Sun. Introduction. When you look at the stars in the night sky, you are actually seeing thousands of suns. A sun is the star in the center of a solar system. Like all stars, our solar system's sun is a ball of glowing gas. Our sun, we call it the sun, even has a star name. Its name is Sol. Sol is a yellow star of medium size. It seems big to us because it is so much closer than other stars. But our sun is pretty ordinary. There are billions of others like it in the universe. You will learn lots more far-out facts about the sun in this book. Just keep reading. Life of Sol. The sun bathes our planet in light. Plants use the sun's energy to make food. Sunlight's heating of Earth creates wind. The sun's rays evaporate water into the clouds that make rain. Without the sun, life could not exist on Earth. In fact, without the sun, there would be no solar system at all. The planets, moons, comets, and asteroids all formed from the leftovers of Sol's birth. More than 99% of the mass in our entire solar system is the sun. The sun seems unchanging to us. It rises each day and it sets each night. But all stars are born, live, and eventually die. Our sun has a long life, thankfully. It's formed out of a cloud of dust and gas about 5 billion years old. It will shine like it does now for another 5 billion years or so, and then slowly begin to die. Yet the sun changes from year to year as it spins and speeds through space. Sometimes it is calm, but other times it rages and boils with solar flares and storms that can hurl danger toward Earth. What causes these storms? How dangerous are they to us? Scientists have found out a lot about the sun, but they still have much more to learn about the star of our solar system. Chapter 1. Watching Space Weather. At 2:45 a.m. on March 13, 1989, a powerful storm knocked out power in Quebec, Canada. 6 million people lost electricity. Some were stuck in elevators or dark offices. Many woke up in freezing cold homes without heat. Others had to drive on roads without traffic lights. The subway and airport shut down. Schools and businesses closed. It took 9 hours to get the lights back on and cost the power company $10 million. What kind of storm caused such a big blackout? Not a blizzard, tornado, or any other kind of earthly weather. The blackout was triggered by a storm on the sun, so-called space weather. It can be difficult for people to believe that space weather can affect life on Earth, said scientist Larry Combs. Combs is a space weather forecaster, but in fact, it can have a tremendous impact on communication and navigation systems, satellites, electric power grids, and astronauts working and living in space. Stormy sun seasons. A storm is a violent burst of activity. Tornadoes are bursts of wind, blizzards are bursts of snow, solar storms are bursts of activity on the sun. How the sun's activity affects Earth is called space weather. Solar storms can shoot clouds of invisible particles toward Earth. These can mess up electric and telephone lines, block out radio signals, and damage orbiting satellites. Stormy space weather can interfere with and damage some of the modern technology we depend on. Solar storms are just part of living with an ever-changing star. The sun is not a simple ball of gas hanging in space. It has an atmosphere, a surface, middle layers, and a center core. Within the sun, hot, dense gases somersault. This constant churning makes electric currents that create a magnetic field. The sun is a huge, powerful, spinning magnet. The sun also has 11-year seasons called solar cycles or sunspot cycles. A sunspot is a dark patch on the sun's surface. Sunspots are areas where the sun's magnetic field is concentrated. When there are more sunspots, there is more unstable magnetic energy. More unstable magnetic energy creates more solar storms. The solar maximum is the part of the solar cycle when the most sunspots appear, and it is also when the most solar storms happen. Sunspot groups often cause severe solar storms, so scientists track them carefully. Forecasting the sun. Tracking sunspots and predicting solar storms is what a space weather forecaster does. Special telescopes constantly take pictures of the sun and measure the energy it creates. Satellites and space probes such as SOHO and Hinode also study the sun. They send their images and measurements back to scientists on Earth. Computers help sort out all the information so space weather forecasters can see patterns and predict what is on the way. Space weather forecaster Larry Combs explained how he does it. The scientist pointed to an image of the sun on a computer screen. "We look at sunspots," he said, pointing to a dark patch on the sun about the size of 14 Earths. "We also look at prominences," Combs said, pointing to a giant bright arc of gas leaping off the sun's surface. Both of these areas can create solar storms. Either can explode in an instant, sending out a blinding flash of energy called a solar flare. Solar flares can reach temperatures of 45 million degrees Celsius, 80 million degrees Fahrenheit, nearly 3 times as hot as the sun's core. Some solar flares stretch thousands of kilometers into the sun's atmosphere, or corona. Each solar flare hurls huge amounts of charged particles and magnetic energy into space. The Quebec blackout on March 13, 1989, was caused by solar flares 3 days earlier. They spewed a cloud of charged particles into space, traveling millions of kilometers per hour toward Earth. The storms were an eye-opening event for understanding what can happen when the sun has its violent moments, remembered Combs. Sounding the alarm. Space weather forecasters are also on the lookout for coronal mass ejections, CMEs. CMEs are explosions in the sun's atmosphere or corona. Space weather scientists call them the hurricanes of space weather because they are so huge and powerful. One CME can send 20 billion tons of dangerously charged material into space in a giant cloud. "We see CMEs all the time from the sun," said Combs, "but the CME is only dangerous when it is facing Earth. Charged particles shooting off a CME on the sun's backside head away from Earth. Scientists become concerned when a CME-making area on the sun directly faces Earth. They call it the kill zone. It's where all the energies are coming straight toward Earth," said Combs. "The Earth is not defenseless. Its own magnetic field protects it from much of what the sun sends out. Earth's spin and sloshing liquid metal center create a magnetic field that wraps around our planet like a shield. Earth's magnetic field pushes away the normal streams of charged particles from the sun, just as one magnet repels another. This normal stream is called the solar wind, and it causes few problems. But when a solar storm hits, Earth's protective shield can be overpowered. Charged particles and magnetic energy that reach through the Earth's protective shield can overload power lines and disturb radio signals." Thankfully, space weather forecasters are there to sound the alarm. "Our primary job is to monitor the sun and to put out the alerts, watches, and warnings for solar activity," said Combs. "Having time to prepare for solar storms makes a big difference. There is a lot engineers can do to prevent damage to power and telephone lines if they know what is coming. Controllers can temporarily shut down satellites to protect them, and communication radios can switch channels. Everyone knows how important storm warnings are. When we have a tornado warning, we know the urgency to get that out to the public, to let people know what's happening," said Combs. "It's the same thing with space weather." Chapter 2. Capturing a Piece of the Sun. Genesis is a mission to find out what exactly makes up the sun. While the sun is mostly hydrogen, It also contains small amounts of other atoms like oxygen, carbon, iron, and nitrogen. Scientists want to know the particular mix of the sun's atoms. Why? Because the mix of atoms in the sun is the same as the cloud of gas and dust that started our solar system 4.6 billion years ago. It's an exciting opportunity to view back in time, to the very beginning, to the birth of our solar system, and try to understand where we came from, explains Eileen Stansberry, a scientist on the Genesis project. Genesis is a robotic spacecraft that collects some bits of the sun's solar wind particles for scientists to study. It was launched in 2001. Genesis traveled 1 million miles away to escape Earth's protective magnetic shield. Then, it opened its collectors to the solar wind. The collectors are thin, round wafers. They are made of strong, pure materials: gold, sapphire, silicone, and aluminum. When fast-moving solar wind particles slam into the wafers, they become trapped like marbles sunk into mud. Solar wind particles are so tiny that you can't even see them, explains Stansberry, but we collected billions and billions to analyze. Genesis collected bits of the sun for more than 3 years. Even so, all its solar wind particles together only have the mass of a few grains of salt. After 884 days of sunbathing, Genesis closed its collectors and flew back to Earth. Once in orbit, the spacecraft released its precious capsule of collected solar samples towards Utah. A smashing success. The September sky in 2004 was clear above the Utah desert. Scientists and engineers gazed up, waiting for the Genesis capsule to appear in the sky. We were anxious, remembered Stansberry. I'd been working on this mission for a decade. A helicopter circled overhead, also waiting. The plan was for a stunt pilot to use a hook on his helicopter to snag the parachute capsule. But the helicopter never got the chance. When the refrigerator-sized Genesis capsule appeared, it was tumbling out of the sky. "It's not supposed to tumble," said Stansberry. "We knew that something was wrong." The capsule's parachute had not opened. There was no way for the helicopter to catch it. The space capsule slammed into the ground at 311 kilometers, 193 miles per hour. It split open, shattering the gold and sapphire wafers into thousands of pieces. Genesis scientists did not give up and go home. They quickly dug the capsule out of the desert dirt and flew it to a laboratory. Thankfully, the wafers had done their job. Most of the solar wind particles were safely buried inside gold and sapphire. How did Stansberry feel when she realized the mission was not lost? "It still gives me chills down my spine," said Stansberry. "We did go out, collect a piece of the sun, bring it back, and we do have it here." It took a lot of work and time to sort and clean all the broken pieces of collector wafers. But scientists are learning lots about what makes up the sun. The Genesis samples are telling the story of the solar system's birth. One discovery is that the sun's oxygen atoms do not match Earth's. The oxygen atoms in the solar wind are more like those found in ancient meteorites. No one knows why Earth's oxygen is an oddball. Genesis is revealing new mysteries for scientists to solve. Chapter 3. What's next for the sun? More than a dozen space probes and satellites are currently studying the sun. In a few years, a spacecraft called Solar Probes Plus is scheduled to fly through the sun's super-hot corona. "We are going to visit a living, breathing star for the first time," said sun scientist Laika Gutha-Hurta. Spacecraft and solar telescopes here on Earth are mapping the sun's magnetic field, taking 3D images, tracking solar storms, and measuring solar wind. Scientists are busy watching space weather and learning everything they can about the sun. It is a very important star. Life on Earth would not exist without the energy created deep inside the star named Sol. The sun bathes our planet in light as it spins between day and night. That sunlight heats our planet. Sunlight also fuels photosynthesis, which allows plants to grow. When you eat fruit or corn chips, you are eating the sun's work. During photosynthesis, plants give off the oxygen we breathe. You can also blame the weather on the sun. Sunlight turns water into rain-making clouds, churns ocean waters, and creates wind. Our sun is a very special star. Far Out Guide to the Sun.